One of the biggest hangups with installing a bidet is the fact that a lot of bathrooms don't have an electrical outlet behind the toilet. So that means you either have to run an ugly extension cord from the toilet to an actual power outlet, or you have to suffer through having cold water, and neither of those options are good. A lot of times it's easier to get power behind the toilet than you might think. So let's walk through that process. Now, often you'll find that there is power on the wall that you're going to use, but that power is either going to be in another room, or it could even be on the other side of that same wall, directly behind the toilet. In either of those cases, you can tap into the power that's coming into that electrical outlet box and use it to feed power into a new electrical outlet box behind the toilet. Once you've figured out where your closest electrical outlet is to run power from, you'll have a couple of different options you'll need to keep in mind. The first is if this location is directly behind the toilet, meaning it's basically in the right spot, just on the wrong side of the wall, then you should be able to run a cable from this electrical outlet to the other side of the wall fairly simply. You just need to tap in to this location and then run a cord in the same wall cavity, which means you're not going to have to cut extra holes or patch drywall anywhere. That also means you won't have to cut any holes between the studs in order to run your new electrical wire through to the new location. So that's the easiest option. If your electrical outlet is on the wall, but it's farther away from where you want to place it, it's still going to be possible to do this, but there is going to be a little bit more work involved. The easiest thing to do is to remove this lower baseboard and remove the drywall that's behind this baseboard in order to have access inside of the wall cavities. Once you do that, you'll be able to cut holes in between the studs in order to run your electrical wire from the power outlet to the new location, and then you'll be able to put everything back once the job is done without a lot of work. Now, we're not going to cover that specific scenario in this video because in our situation, where we want to put the electrical outlet is actually on the exact opposite of where this electrical outlet already is. But if your situation is where you have power that's further down the wall, I'll link to a video that will walk you through that process step by step down in the video description. One of the easiest ways to find studs is to use a magnetic stud finder. The way this works is there's a couple of strong magnets in this, and as I run this along the wall, the strong magnets will attach to any metal parts in the wall. So in this case, it would be either a screw or a nail in order to locate the stud. Now, while these are really convenient, they are limited to what they can detect because, again, they're just looking for the metal fasteners that are pretty much at surface level within the drywall. If you're looking for things that aren't necessarily metal where these can attach to them, then you need to go with the traditional stud finder. So you can see here as I turn this on, if I go along this location, you can see these three lights lighting up directly where the stud is. So it doesn't have to depend on any kind of metal fasteners to detect it. The other thing that's interesting is studs are supposed to be spaced about every 16 inches in a wall, but as I run this stud finder along the wall, you can see here that it's picking up another stud or something in the wall at this location. So I'm glad I took the time to use a stud finder to find this other stud here and not just assume that it should be another 16 inches over and not just rely on this magnetic stud finder as well, because I wasn't able to pick up anything with this either. The only thing the magnet detected was another stud that's about 16 inches away, which is what we expected. In areas that have plumbing, it's always a good idea to take your time, be cautious, and try to really understand what's on the inside of these walls before you make any cuts. We also want to take a measurement to see how high the box is off of the floor. So you can see here the box starts at about 12.5 inches from the floor. So we want to make sure that that's consistent with the other electrical outlet box that we're installing. We have only a few inches between this outlet box and putting in another outlet box because there's a stud here and then there's another stud just a few inches away. So we're going to have to be very accurate in terms of how we're measuring this when we cut the hole. The way our wall is set up in this bathroom, we have about 3 inches from the edge of this trim to the wall. Also, we know that a standard interior residential wall is about 4.5 inches thick. That's because a 2x4 is actually 3.5 inches wide, and then you put a 1/2 inch layer of drywall on both sides of that, you have 4.5 inches. So in our case, we have about 7.5 inches before we reach the inside of this bathroom closet. So we're gonna subtract that from the total distance from where this trim starts on the other side of the wall to the existing electrical outlet box. So between the trim and the start of the electrical box, we have exactly 15 inches. So if we subtract the 7.5 from the 15, we have exactly 7.5 inches. So that means the inside of the bathroom where the toilet is on the other side of this wall, that wall where it starts is actually right about at this 7.5 inch mark. So we've got another 7.5 inches for this electrical box before it starts in that bathroom. And that means we have only about 5 inches total between the next stud and the edge of this electrical box. So since our new electrical box is about 2.5 inches wide as well, we do have enough room to put this next receptacle in this same cavity, although it's going to be a little bit tight. So what we'll do is we're going to measure out another inch on the inside of this wall, and that's what we're going to aim for to start our new box. And that'll give us another inch to play with between the other stud and the edge of the new box. And of course, when I say an inch to play with, I mean an inch of margin. So we're gonna have 1.5 inches of margin on one side and about 1 inch on the other side. It's gonna be tight, but we're gonna be able to make it work. Okay, so to show where this lines up with this wall on this side, this blue painter's tape here, that's actually where the electrical outlet starts on the other side of the wall. And then this bottom tape here indicates the height. So you can see that other electrical box is sitting pretty much directly behind this toilet. So for us to install the other electrical outlet box on this side, we're not going to have a lot of room without having to remove the toilet. So what we're going to do, instead of pulling this entire toilet, I think we can just remove the back tank. So what I'm going to do is I'm going to drain that tank, unbolt it and remove it so we have more room to work. And we need to shut off the quarter turn valve, and then we'll flush. Now there's still going to be a significant amount of water in the bottom of the tank, so we'll have to use some old towels and some sponges to get that all out before we unbolt it. Now we'll put a towel underneath here, and we'll disconnect our supply line. And now to remove the tank, we can reach the bolts underneath and remove those. Since we're working with such tight tolerances, I went ahead and decided to pull out my laser level since we don't have a lot of margin for error here. So what I did was I outlined the outside of the box that's on the other side of the wall, mainly just for a reference. But with this inner piece here, since this is exactly 1 inch and we're planning on spacing that next outlet box 1 inch away from the existing one, I thought this would be a good reference point to make our first cut. We'll use this as the straight edge for our new old work box. And as you can see, that box is going to be pretty much directly behind the toilet, so it's a good thing we remove that tank. Otherwise, we wouldn't be able to access this. So I'm going to take this old work box, I'm going to line it up down here, and I'm just going to outline this box with a pencil, so that way I know where to make my cuts. Just use this as a straight edge here to mark the rest of this path. Because if we account for this tab here, if we take this off, then we're not going to have any place for this to set on the drywall. So we've got to make sure that we're marking inside here. So that bottom mark that I made is wrong because I used this tab. I wasn't paying attention. So I'm going to go back and do this again. And you can see how much further up this line is compared to what I marked originally. So now we'll go back and we'll use this as a straight edge again. And we'll mark this across. Okay. That's why they always say, measure twice, cut once. Now the problem we have here is since these tolerances are so tight on both sides, I'm not sure if I'm going to use a drywall saw or not, or just stick with the utility knife for the full cut. We'll see what happens. Here I'm just slowly working my way through the drywall using the utility knife. Again, I'm just trying to be careful not to go too deep and accidentally cut through something on the inside of the wall. It's always best to be cautious when you're doing something like this. This was not a stud that was in the wall, it was actually a vent stack. So it's a good thing we use that stud finder to not only find the stud, but also find this plastic that was in the wall. So we're gonna dry fit this box and make sure this hole is big enough. If it's not, we'll trim it out a little bit. And it looks like I cut it a little bit too tight. So I'm gonna trim this drywall up now. Make sure there's enough room for this to fit in here. I'm just using my blade to scrape away some of the drywall. Take it out a little bit at a time. Don't want to take out too much. I want it to still be a nice tight fit, but not so tight you can't really get it in and you're risking breaking the drywall. And obviously I could have taken this tape and taped it around the exact location of where I wanted the hole to be, but I wanted to make sure I knew 100% where this other outlet box was so I could avoid it. Looks like that's going to do it. Okay. To figure out exactly what breaker supplies power to this receptacle, I'm going to be using the circuit breaker finder. So all I have to do is plug this end into one of these receptacles, and then I can go to my breaker panel and find it with the receiver. And now we're going to take a non-contact voltage detector and double check to make sure all the power is off to this receptacle, and it is. And we're going to remove the receptacle. So the goal is to run new Romex wire, this is 14-2 wire, through this box, from this box, and go inside the wall and out that hole that we just cut. Sometimes these boxes have a way to punch through the back so wires can get inside of the box. Sometimes they're more of like a spring-loaded plastic clip that you have to work with. It looks like in our case, this is just one that it's weak in the back so you can punch a hole through it. And instead of going through an existing hole, since they're only big enough to run one set of wires, we're going to punch a hole through another side here to run our Romex wire through. Okay. Now we can take our new wire and run it inside of this wall cavity and basically fish it out the other side. And then I'm going to run this in the box and kind of lay it over. So I'm going to go on the other side of the wall and try and pull this out. Since there's no power in this room now, because we turned the power off for this, this outlet on the other side, I'm going to have to use this light and then reach in and see what I can do here. So you can see the new wire inside this wall cavity here. It's coming out of that old box. So I'm going to reach down, grab it, and pull it through this hole. Okay, I'm going to feed a little bit more wire in through this hole just to make sure we have enough to work with. Okay, back to the other side. We want to cut off this wire to about the same length as the existing wires that are in the box. So about like that. And we're going to strip our Romex off here. Just going to cut down the center. Not go very deep. And okay. All right. Get rid of this paper. We need to strip these wires. Use some wire strippers to do that. Now we need to disconnect this receptacle. If the terminal screws are used, you can simply loosen these screws to remove the wire. But in our case, these are installed in what's called a backstab method. There's typically a slot that you could put in like a tiny screwdriver to release a clip to be able to pull these out. But honestly, I find it's easier to just cut these wires off. So that's what we're going to do. Cut them close to the receptacle. And for the ground wire, we will unscrew it. Since this is an older receptacle, it's kind of worn here, and because I cut these wires off, we're going to replace this receptacle as well. So I'm going to grab a new one. Whenever you're replacing or installing new electrical devices, make sure they're up to current code. So the receptacle that we pulled out did not have any kind of tamper-resistant doors on it, which is code now. This one does, this replacement one does, so this is going to be going back in place. Also, this is considered a spec grade receptacle. This receptacle can actually be back wired, so instead of having a little clip that holds the wire in place, there are actually clamps that will hold the wire in place. So this is definitely going to be superior to the one that we pulled out. Now we do need to strip the old wires since we had to cut these off of that old receptacle, so let's go ahead and do that. To install these wires now, we're also going to be switching up the method. Instead of having these go directly into the receptacle, since we have another pair of wires here, we're going to use what's called a pigtail method, which is basically putting all these similar wires together with a wire nut and then having another wire come off of that nut and make its connection into this receptacle. Instead of using a traditional wire nut to make these connections, we're going to use what's called a lever nut. So basically, instead of having to twist all the wires together with this cap, you just simply have to lift these levers up and insert your wire and then close them down, and the connection's made. So let's start with our neutral wires and hook these in. And we'll do the same for our hot wires. Now for the ground wire, I actually am going to reuse this nut just to make sure it's a continuous ground. You could probably use a Wago nut connector instead of doing this, but I'm just going to go ahead and reuse what I've got. Tighten that back down here. Put this back in the box as far as it can go. Now we need to take a piece of spare wire and make our pigtail connections. So we'll cut off about 4 inches. We'll take the wires out of the sheath, and then we'll do the same thing. We'll strip off the ends on both sides of these wires. So I'm using 5-port Wago connectors. They make 2-port and they make 3-port as well, but since we have so many wires in this box, we're switching it over to pigtail. I went with the 5-port. Okay, so now those are ready to connect up to our new receptacle. First, we're gonna hook up the ground. We're gonna make a J-hook. We're gonna feed it over the ground screw. We're gonna tighten this down. And then we're gonna use these back wire connections. We're gonna make sure that the wire is in between the clamp and the plate, and then we're gonna tighten it down. The brass terminals are for hot wires, and the silver terminals are for neutral. Get all this extra stuff in here. Put our cover plate on, and then we'll go over to the new location. For the new receptacle that we're installing, we need to make sure it complies with code as well. So that means we need to install a GFCI receptacle. Now, GFCI simply stands for ground fault circuit interrupter, and it's required for any damp locations like a bathroom because the odds of this receptacle or a device that's plugged into it coming into contact with water goes up significantly. And obviously water and electricity don't mix, so a GFCI has to be used in this location. The next thing we need to do is feed this wire in through this box before we put this in place. So I'm going to go ahead and run this Romex wire in through this port. Just going to push it down back here. And this is one of those spring-loaded versions that I was telling you about. The reason we're doing this now instead of waiting is because if we waited, we would not be able to get this wire fed through. It would just be too tight of a location to work with. So we're getting this wire through the port now. Okay, and you can push on this port in the back and pull through at the same time. That can help make it a little bit easier. Okay, so now we'll make sure these fins are folded in, both the one on the top and the one on the bottom, otherwise this won't be able to go into the wall. So make sure those are flat up against the box. Then we'll push this in place. Make sure it's flush up against the wall. We'll take our screwdriver and we'll tighten these wings down. So that wing is popped out on the inside, and as I'm tightening this, it's pulling that wing towards the drywall to squeeze between the drywall and these blue clips here. Just snug it down. Now we can prepare our wires just like we did before. Make sure there's about 6 inches of wire sticking out here. We don't need a ton, and I pulled a little bit more than I needed just to be sure we had enough. So I'm going to cut off a couple inches here, and I'm going to remove the Romex sheathing, same as before. I'm going to cut down the middle, not going very deep, just enough to cut through the Romex. I'm going to cut a little T in the back here, Romex sheathing off. I'm going to get rid of this paper. We're going to strip these wires. Now we're going to wire this in using the line terminals on this GFCI. GFCI and AFCI receptacles have line and load terminals. Make sure that you're using line when you're putting power into this, and load would be power coming out of this receptacle going somewhere else. So always remember line in, load out, and if you only have one set of wires, it's always going to be line. Black to brass, so neutral goes to silver. And then we can make our ground connection. In this receptacle, we can feed a straight wire in behind this plate. We don't even need to make a J-hook. Fold these wires, push this in place. Then we'll install this cover. And we'll go turn on the power.
I can't really do much right now.
And we'll test it for good measure. Looks like we're good to go. Now that the electrical work's done, we're going to wrap things up by putting the tank back on the toilet. When you retighten these bolts, you want to make sure you use even pressure. Tighten down one side and then the other. Don't over tighten because you will crack the porcelain. Tighten until there's no gap between the tank and the toilet. And then once you feel resistance, stop. If you're not quite sure if you need to tighten this anymore, just try and rock the tank back and forth a little bit and it shouldn't move. If you found this video helpful, be sure to hit the like button and also check out this other video next. I'm sure you'll find it helpful too. Thanks for watching. I'll see you in the next one.